You might hear many people talking about risk-based testing. It sounds good, but not many people have a deep understanding of what risk-based testing is. In a nutshell, risk-based testing is basically thinking about the ways in which our systems can fail and using that knowledge of the modes of failure to direct and focus our testing. But risk-based testing is only based on some certain types of risk. So we need to start at the basics and ask, what is a risk anyway? So, what is a risk? Now, you might not want to adopt a very formal risk management approach in your projects, although others may do. But even if you don't adopt a very formal approach, a deeper insight into what risk is and how risk-based testing can work will help you in your testing. Now, the first thing to say is there are many definitions of risk if you look them up, and to be honest, the best one I think as a starting point is the Italian derivation, risicare. I can't pronounce Italian words, but there you go, meaning to dare. And this notion of daring and ambition is part and parcel of all projects, but all projects come with risk, things that can go wrong. And really that's all a risk is. It's something that can go wrong with your project that affects you and is in an important way. The most useful definition I have as a basis of risk-based testing is this one. A risk threatens one or more of a project's cardinal objectives and has an uncertain probability. I don't use that definition every day, but it helps give you the mission statement, if you like, of risk-based testing. Now, before I start on what risks are, let's look at some general statements about risk. What is and is not a risk? The first one is risks only exist where there's uncertainty. So, for example, if you identify something that could go wrong, but you believe that it is never going to happen, the probability is 0, well, it's never going to happen. So why worry about it? It's not a risk. If the probability is 100%, that is, it's guaranteed to happen, you know it's coming, that's not a risk either. So if there's a hole in the road, you know when it's coming, you know where the hole is, you could see it, and you have to take action to avoid falling into it. It's not a risk in that respect. There's no uncertainty involved in it. Now, one thing we can say about risk is if there's no potential for loss, there's no consequence, there's no impact that we care about, that's not a risk either. If there's no potential for loss, it's not a risk because we just don't care. It doesn't matter in that respect. Now, what I have to say is that with every project, things can go wrong. With every software project, software development itself is inherently risky. We know things can go wrong. In fact, we've never been able to produce perfect software, certainly not on day one. We know we need to do some testing. So let's touch on cardinal objectives, just so we're clear about what these things are. The cardinal objectives are, if you like, the fundamental goals of a system to be built, the goals of the project. Now, those goals might be benefits of some description, of course, and there might be some monetary income or revenue to be obtained through the successful completion of the project, or there might be some kind of cost saving. So usually there's some payoff that underpins the project itself. The reason why stakeholders are investing money in this project is because they want to make or save money. Software risks are those that threaten these cardinal objectives, these fundamental goals of the system itself. Now, there are lots of different ways of classifying risk, depending on what you want to do with respect to your risk management. So I'm just going to show the 3 types which make the most sense to me and I hope to you. The first one is project risk. That is, These are effects that come from external to the project, almost acts of God, if you like. So things like not having enough resource, external interfaces, suppliers, customers, not behaving themselves, not delivering, not collaborating, contributing that way, or a contract that's unduly restrictive. These are all things that tend to be imposed on us as project participants. Now, these project risks are mostly a management responsibility. They have to get around these risks and to reduce them or avoid them completely if possible. The second category is process risk. And if you like, these are risks that are internal to the project. So these are things like not doing sufficient or adequate or accurate planning, perhaps. Maybe we don't get the right people, or we don't get enough people to resource our projects. Maybe we don't do enough testing. The lack of QA, lack of focus on preventing bugs as well as detecting them, of course. Not controlling change in a good way. Another is something that's under our control. It's internal to the project. Again, it's a management concern in general. Now, the third type is what we call product risk. That is the product of the project, the software, if you like, the software implementation, where that is at risk itself. You could call it the risk of poor quality as a qualitative way of looking at this. But essentially, if we have requirements that are poor or requirements that are changing, if there is complexity in our systems, and that's inevitable, of course, there might be unplanned levels of performance required, or security, other non-functional issues. These are all product risks, and these are primarily the main concern of testers. Now, testers are concerned with everything, every kind of risk, but we don't have much control or much of a contribution to make to project and process risk. Product risk is our concern. Now, it would be nice if we could quantify risk in some way, because what we really, really want to do is look at all the things that can go wrong, look at the most critical of those risks or modes of failure, let's call them, and focus on those first. Certainly do them in a sequence that makes sense. Of course, not all risks are addressable, if you like, or mitigatable, if that's a word. But when we try and quantify risk, there are two kind of dimensions to them. There's the probability of this bad thing happening, and we tend to use a percentage for that, for probability as a percentage. The second dimension is the consequence or loss or severity, and usually we'll try and put some kind of monetary figure on the cost of that failure materialising. Now, it's nice to use numbers for calculations and comparisons and spreadsheets and all that other good stuff, but at the end of the day, you have to recognise that we're dealing in perceived risk, not absolute risk. Risk is very often a subjective matter, depending on which stakeholder you talk to. So we'll come on to this issue of both uncertainty and subjectivity a little bit later. Now, suppose we ask people to assess risks in these two dimensions, probability and, let's say, severity. Of course, with probability, we can have ranges of percentage probabilities, assign a description. Maybe we give it a score. 5 is terrible, 1 is we don't care. Severity might be in a similar kind of tabular format, the labels we assign to our risks, going from critical, it's absolutely disastrous if this thing happens, to negligible, we don't care. Now, the issue is, we can, if we get numbers, calculate something called exposure, if you like, the scale of the risk. And risk exposure is usually calculated as the product of the probability and the consequence. One way of looking at it is also to look at likelihood and loss. It's the product of likelihood and loss, the cost of the risk materialising. But what do these numbers mean? Well, sometimes, not very often, but sometimes we can use these numeric assessments to treat risks as if we could quantify them in an objective way. We might have some experience. So if we've had a disaster in the past and we want to prevent it in the future, it's a risk of concern, we might know the exact cost of that disaster happening in the past. But certainly with probability is we're often just guessing. It's a shot in the dark. And so maybe we can only assign red, amber, green labels to our risks to say they're serious, of concern, or they're not of concern at all. The essential thing for whether we use numbers or not is what we really want to do is to be able to compare risks, to prioritise them in some way. And that's what's most important. Now, how we do it, whether we can use numbers, which is maybe a bit suspicious for many people, or we just use a subjective view and have a conversation about prioritising, maybe that's the only alternative we have. Let's look at the notion of qualitative risk. Well, it might be that we can't imagine the numbers being accurate when we try and assess risks in a systematic, numeric way. So we might simply say that the probability is high, medium or low. We might suggest that the consequence, the loss, the severity is critical, moderate or low. And if you like, when we have the conversations about risk and we use the language of risk, high, medium, low probability, critical, moderate, low, consequence, we can get a deeper understanding simply by comparing people's perceptions of risk and use that to help us judge which risks are more important than others. And essentially that's what we need to do. We need to prioritise in some systematic way so that we address the risks of most concern. Now, one way of presenting this would be to say that critical and very highly probable risks are our biggest concern. So they would be top right and coloured red in this little diagram. And of course, the negligible risks that are very unlikely clearly would be, we wouldn't care about them. So that we might label those green. And you have an orange region in the middle between other areas. Now, I'm not saying this is the way you should do it, but essentially what we're trying to do is move risks from being very likely and business critical to negligible and highly unlikely. The critical thing about what we can do with risks is we probably can't easily change the consequence by changing software. What we can do is by testing and fixing bugs in software, perhaps reduce the perceived probability of failure. And that's what testing does for us. It helps us to reduce the probability of a risk materialising. That's the critical relationship we need to understand. Now let's talk about uncertainty a little bit. Uncertainty of the consequences. I mean, do we really know the potential cost of a failure? We might have some idea, it might be very dramatic, but a lot of the consequences of failure are things like commercial credibility or embarrassment. There might be legal issues and penalty clauses in contracts where we fail to deliver a good service, and those can be quantified, of course. But by and large, consequence is quite tricky to calculate in a meaningful way. What about probability, though? What is the probability of a particular mode of failure? This is the toughest one to call. And some people might say we're simply crystal ball gazing. We can't make these predictions. But we can have a professional judgment of whether something is more likely, but also whether something that we fear could be reduced in terms of its probability through good testing and getting evidence out of good testing. Now, I want to spend a moment not on risk management in the round, but what are our responses to identifying a risk of consequence? Well, there are several things we can do. Obviously, the do-nothing approach is always available to us, and for negligible risks, that is our response. But mostly we're concerned about things that have serious consequences and a realistic probability. The two aspects where testing fits are things called information buying and process model. Information buying is about gathering evidence to give us evidence of the behaviour of our systems and software in scenarios that have meaning to our stakeholders. And when we run tests that demonstrate the system working, and when we detect a failure or cause a failure, and we fix the bug, and we retest and regression test, this is all providing evidence that builds confidence provides information, and if you like, testing is buying information in that respect to help us make a reassessment of risk with a lower probability of failure than perhaps we thought initially. The second aspect is a process model. It could be that there are risks which we hadn't considered at all or hadn't thought through in the early days of a project. So it might be, it's very common for example, performance testing to not be thought about until quite late in the day. So if you like, the process model idea is that we change our process. We add an extra level or layer or stage of testing to do maybe performance testing or security testing if that's been overlooked, or there's particular functionality that we thought was reliable but turns out not to be quite as reliable as we thought. So we change our process, and that's what testing does. The other measures that we have really aren't related or relevant to product risk, which is our main concern as testers. Finally, testing and evidence can reduce uncertainty to some degree. We can't ever promise that there are no bugs left in the software. What we can do is provide evidence through tests, demonstrations, if you like, of the system working in ways that it should, and where we encounter failures, we fix the software, fix the system in some way, retest and regression test to eliminate, as far as possible, uncertainty. But we can never, ever eliminate uncertainty 100%. And that's our experience, whatever kind of projects you work in.